So last lesson we looked at how to mix it up so that we had all three LEDs going using three motor speed tools to get the PWM. We also looked at how to copy that lookup table results into three different registers, GD1, GD2 and GD3. And we looked at how to use those three counters to modify the result for each of the GD values so that it had the shift and broke the sine wave up a little bit, giving us a nice flickering pattern. Well, this lesson is lesson 8, saving private sine. The sine will take up lots of code, but we can share it in a subroutine and save it for later. Well, this lookup table, if we have a high resolution on it or a high length, it actually uses up lots of data. If I leave it on a low length and we look at the program in the assembly code, we'll see it's got a table that's just 16 values long, index 0 to 15. But the larger we make that table, or the more length we put in that table, you'll see if my length is 102, then it's going to have the values from value index 0 all the way up to 101. And we want the highest resolution to make our sine wave nice and smooth, so we're using 240, and that uses up almost half of the memory on this microchip. So the lookup table is a little bit private because if we try to put another one on, it's going to show us that there's an error. And the error says there are too many lookup tables with large amounts of data so that the last lookup address exceeds 255. Please reduce the total amount of lookup table data. Now, we can do that by making our length shorter. We can have more than one lookup table. But, like I said, we need a high resolution to get a really nice smooth curve. So we're going to share that lookup table in a subroutine. Now, to do that, let's try and just understand what we've done with this program so far. There's 4 stages. The first stage is start and turning the pins all off. That's a bit of a easy one to think about. The next stage is this motor tool stage that's generating our pulse width modulation. And so at the moment we're running that through 500 times, and that's really quite a fast value to go through 500 times, and then it goes and looks up the rest of this just once before it goes and does this section 500 times again. Well, that's stage 2, we could say. Stage 3 is our lookup table. So we're generating a count, which is a number between 0 and 239, which corresponds to the length of our data in the lookup table. And that count is being placed on the working register. The lookup table finds that value, and then it outputs a result onto the W register. And that's all done here. So that's, we could call stage 3. Stage 4, we're going to take the result from the lookup table, and that's what these 3 file tools do, and then it's modifying that result to give us that shift of the sine wave to give us the flickering pattern. So that's what we're doing with the result of the sine wave. That's the stage 4. So to save private sine, what we're really trying to do is we're trying to get the sine tool and this part, taking the results, and we're putting that in a subroutine. So we're just going to copy and paste those two for the moment, and we'll place it down here. Now we'll delete the lookup tool because we're not going to use that one. And we're going to place our 2 tools down the bottom into a subroutine by using a sub start and a sub end. Now just checking, we've got all the data still in our sine wave, that's good. That'll put it in the right place. Let's align those horizontal and distribute horizontal. Now what we need to do is we need to think about this file register tool and why we've got it here. Well, the file register tool is taking a value from the working register and we're going to place it in our memory. And the reason we do that is if we leave it on the W register, this end tool, subroutine end tool, always modifies the W register when it exits a subroutine. So we can't leave anything on the W register to access it after the subroutine on this microchip. So that means that we need to place the value from the working register in a temporary register. And we're going to do that. We're actually going to modify this first one. Instead of it being the counter register, we'll make it temp. And that'll just clear things up for later. And we'll modify the actual annotation there as well. So it says working into temp. Now what we have to remember is this counter was using that same register at the top. So we better go and fix that up. So in the counter, we go to the increment and you'll see it's on temp. We actually want to go down and we're going to create 3 registers, count 1, count 2, and count 3. And we'll choose the first one, count 1. So same thing with our first file register. We need to make sure that that's also sending count 1 to the working register, which it is now. Okay, so lastly, or almost lastly, we'll place in our subroutine and we'll link it up like so. Now that subroutine, we're also going to make it look like a lookup tool by unchecking use default background. We'll click on the lookup table and there it is. Now the last thing we want to do is these duty values, we're no longer taking them from W because W just has that result from the subroutine end. We actually want to take them from temp. So if we go into this tool and we choose file to file, instead of it being from working to file, we're going to make it from file to file transfer, and we'll choose from temp to duty 1. We'll go into the second one, we'll make it a file to file transfer, automatically getting temp there. And the third one we'll do the same, file to file, temp onto duty 3. And we can update those 3 values on the system design to show us it's the temp being moved into the duty registers. So the rest should work the same way. Let's program it. And we can see they're all flicking away as normal. So instead of us having the lookup table here, we're diverting into our subroutine. The subroutine is now sharing it onto the temp register, and we're accessing it in each of these file tools, transferring the temp onto the duty registers, and it works as normal. So we haven't really done much this lesson because it's still the same visual outcome, but this just prepares us for lesson 9. We're actually going to access the subroutine 3 times, even though we only have one subroutine lookup tool. So save your work, print it to PDF, show it to your teacher, and that is lesson 8, saving private Sine. Thanks for watching.